Hello once again everyone. Today's lecture is going to be very interesting because we are going to study first practical example of diode. Of course, whatever we study so far is of no use if we don't know what is the advantage of using diode. So today we will discuss diode as a logic gate. So we all know what are logic gates and what is the purpose, how logic gate work, how AND gate works, how OR gate work. We all know about them. But the question arises here is why we need logic gates. Okay, we know what are logic gates, but do you know or do we know that where it is the application of logic gate? So before going to the topic of discussing how we can make logic gate using diode, first we should know that what are the application of logic gate. So logic gate have lot of example. For example, you have a fire alarm system in your home, in your company, in your factory, anywhere. So there are a lot of fire alarm at your home. There could be multiple fire alarm in your rooms. For example, you have 3 rooms in your house and you put a fire alarm in every room. You also put one in the garage and etc. So but have you noticed that the buzzer or the sound is one? So what happened is any of the fire alarm start ringing or it detect the smoke or fire, what happened is the buzzer start buzzing. How it happened? This is the application of OR gate. Any one of the alarm get the signal high, and how it get the high? When it detects the smoke or fire. So whenever any of the smoke detector or fire detector detect the smoke or heat, it gives the signal to its panel, and in the panel there is the logic of OR gate, and on that basis they generate a buzzing sound in the buzzer. Similarly, there is a definition of AND gate. For example, there is thing where you need to be sure about, or where you want to be check two condition. For example, you want that alarm will buzzer only when there is X time of pressure and the temperature should exceed Y value. For example, if the pressure is above 2 bars and temperature is also above 50 centigrade, only then you get the indication. So in such scenarios you will use AND gate. So in industries this is the normally what we are doing. So if there is some silo tank, or there is some process, or there is some reactor, so we are continuously looking at it pressure, we are looking at it temperature and other parameters, and we have put the logic of AND gate sometime where it is required that if the temperature is exceeding to this value and pressure is also exceeding to that value, it means there is something wrong, and in that case there should be an alarm. So we, in such scenario, we will create a AND gate. So like this there are a lot of example where we use AND or NOR, exclusive or an exclusive AND gate. So like this you can search a lot of application, you can create a lot of application. So moving forward we will start about discussing few of the logic gate in today. So we are going to discuss about OR gate and AND gate. So how we are going to make a AND gate or OR gate. So let's see to this diagram that how they are working. So what we can see, or before starting this, I am telling you one thing, that in today's lecture what we are considering is that the diode is ideal. This is ideal. The ideal diode mean it has a potential drop of 0 volt. Okay, the real diode is considered to have a potential drop of 0.7 volt, but just for the sake of easiness, what we will discuss in today's class, or what we will assume in this class, is that the diode is ideal and its voltage drop is 0 volt, so that it's easier for you guys to understand. So whenever I say 1, it means power. It can be 5 volt, it can be 9 volt, it can be 12 volt. So whenever I say logic 1, it is voltage, and when I say logic 0, it means 0 volt or ground. Clear? So let's start discussing this today's lecture. What we are going to see is the diagram in which this is the resistor is already grounded, and what we are going to do is we are going to apply the voltage here. Let's first apply 0 volt on these two. When you apply a 0 voltage at the positive side of the diode, and you can also see that the negative side of the diode is also connected to the 0 volt, so there is no potential difference, hence the output Z would also be 0 volt. Now if we convert this 0 to 1, any 1, now when you applied 1 to the to one of the diode, let's say we have did this with X, what you can see is now at this side of diode is 5 volt, and this side of diode is connected to the ground, hence this is now forward biased. As it is forward biased, now the voltage going to appear at this side of resistor is 5 volt. Now in this scenario, what we can see, the output comes out to be 1. Similarly, now let's apply 1 to this one, the Y diode. The same effect will happen when you put the 5 volt here. This whole node will be 5 volt. So because I'm considering ideal diode, so the potential drop across the diode is 0 volt, and the voltage I applied at this side is coming toward this side, and this diode goes to the reverse bias condition. Likewise, in the previous slide or the previous our discussion, when I said this is 5 volt, then the blue diode was reverse biased. So now this node is 5 volt, hence the voltage drop across the resistor is 5 volt, and at Z you are getting 5 volt or 1. Similarly, if we put 1 on the both side, both are 5 volt, both are forward biased, and this node is again 5 volt, hence the output is 1. So by this what we have seen is that the output is 0 only when both of the input are 0, and output is 1 when any one or both the output are 1. This means right now this circuit is working as a OR gate. Now look at the other diagram. Here what going is that we have applied voltage at this side. This can be 5 volt, this can be 9 volt, this can be 12 volt. Voltage can be any value bigger than 0.7 volt, which is the diode drop in real case, and in ideal case, as we are considering the voltage drop across the diode is 0 volt, so even 0.1 volt would be enough, but in reality you at least need voltage source of 0.7. So now let's see what's going to happen. Suppose that we have connected these two to 0. In this condition, the diode is forward biased. Why? Because there is a high potential and there is a low potential, and when there is a low potential, it means that diode is now forward biased, and as we are considering the diode is ideal, so the voltage appearing at this end will appear at this end, and hence it will be 0 volt. So all the voltage drop would be across 5 volt resistor, and the output would be 0 volt, right? So if I consider a real situation, what would be happening in real condition, that this is grounded, and as there is a drop of 0.7 volt, hence the voltage at this point would be 0.7, and the drop at resistor would be 4.3 volt. Hence the output you are getting is 0.7 volt, which is nearest to the 0. Hence we will consider this 0. Now let's suppose that we do one of the output 1 and another is 0. As this is 1, or this 1 is equal to V, so this diode will be reverse biased, and this diode will be forward biased, and this will conduct the electricity, and the voltage drop across it considering 0 volt. Hence this 0 will be appearing at this side, and hence the output would be 0 again. Now if I connected both sides with 1, which is equal to the voltage drive you have attached, now both the diodes are in reverse biased condition, and hence the as there is no current flowing through the circuit, so the voltage appearing at this side of resistor will also appear at this side of the resistor, and you will get 1 at the output. So by this what we saw is that this circuit is giving you 1 only when both the inputs are 1. Hence this works as AND gate. Just to make you more clear, as I know that AND gate circuit is little bit complicated as compared to the OR gate circuit, so I'm just going to show you in little depth. Sorry. Okay, so this is the OR gate. So this is an AND gate, and we can see that in this situation, when both the output of diode are not connected to the ground, the output is 1. Why? Because there is no potential drop, and the circuit is not completed. Hence the voltage at this end is appearing at this end, and you getting the output equals to 1. Hence when both the output are 1, you get 1. And whenever there is any one of the output or any one of the diode connected to the ground, the circuit will flow the current through it, and you get 0 at the output side. Always remember at what point you are taking the output, because if you change the point of taking the output, the voltage obviously would not be the same. So that's how AND circuit is work. This is eagle view of what we have discussed so far, that this is a OR gate, this is an AND gate, this is a table. You can check by your own self that whenever you apply 0 volt, the output you get is 0, and whenever there is only 1, you get the 1. You can check all the input and output of AND gate and OR gate, and if you have any question, you can ask me in the comment section. I will be readily available to reply on your question. So let's move forward. Similarly, what we discussed up till now are 2 diode. Now you can connect as much as diode you want to make the to increase the input. For example, if you have 3 inputs A, B and C, you can connect 3 diode in parallel, then resistor, and then a negative volt power supply or a ground. So now whenever you give 1 to any of them, for example I give it 1 volt, and rest those 2 are 0 volt. So we can see that as this is at positive side, the diode will be in forward bias condition, and whatever voltage you applied at this point will appear at this end, and you will get 1. So you can see that also here what you are going to get. Similarly, if you put 2 out of them to 1, you will get 1. If you put 3 of them to the 1, you will get 1, and you will only get 0 when you make all of them 0. Similar is the impact when you connect diode for AND gate. The only difference is that you are going to connect the voltage source with the diode anode. However, if you look at that, here we connected supply, the negative supply. In OR gate we connect cathode of the diode with the negative side of the supply, and in AND gate we connect the anode with the positive end of the supply, and we give signal at the cathode. So you can again test this as we test the previous circuit. If you give 1 to any of the circuit, any of them, the output will be 0. The output will be 1 only when you give 1 to all of them. Why? Because if any one of them is 0 volt, the circuit will flow through it and you will get 0 volt here. So similarly, obviously, how will you test? So the simple way, if you want to try this at home, you can connect a LED. Obviously you cannot put a multimeter and change the signal and try it every time. What you can do is take 3 diode, make the circuitry as shown in the figure in front of you, and just connect a push button with this and give it a 5 volt or ground. So whenever you press the push button, the 5 volt pass through it, and when you stop pressing the push button, it will get a ground. Hence, in this manner you can try this at home and you can check either the circuit is working or not. And if you get any complication in trying this, or your circuit is not working, you can connect with me on the comment section. So I will be readily available to help you and guide you if there is any mistake in your circuit, and I will tell you what changes is required to make it work. So by doing this, you will see that whenever you apply 1 to any of them, the LED will glow. Similarly, in the AND gate, when all of them are 0, the output will 0, and the output will be only 1. It will only glow when all of them are 1. So you can try this at home, and if you have any question you can ask me, and I will be readily available to help you guys. And what we have discussed so far are AND gate and OR gate, but however, using diode you can create as many as gate you want. You can create NOT, you can create NOR, you can create exclusive NOR, you can create any type of diode. So that's I'm leaving to you. You guys try making other type of gates, and if you guys have any issue, for example you want to create a XNOR gate and you weren't able to create it, you can connect with me with your circuitry. I can tell you what is the missing part in your diagram or your schematic, so that you can correct that. So let's try it at home and give me your feedback. That's all for this lecture. I hope this is informative. I will be back soon with the next lecture. Till then, stay tuned and please subscribe my channel, and also ask your friend to subscribe it. Thank you.